Hello, myself Dr. Murali, Associate Professor and Head of the Department at Laxman Reddy Institute of Technology and Management, Dundigal, Hyderabad. So, in the continuation of previous video, now I am going to extend the next problematic thing on influence lines diagrams by using bridge engineering. So, and we'll solve one problem related to how two or more loads are acting on a particular simply supported beam. So then how the reaction, shear force or bending moment will vary from one point to the another point. We'll see. So let us take one example. This kind of, for example, there is a bridge having two supports. So there are two cars are traveling. So one car like this, there is another car which is spaced at 2 meters apart. So when two cars are crossing support A and it is traveling to support B, so there is a variation of reaction, shear force and bending moment at different locations. In the previous video we have seen, irrespective of original load, we have to calculate the for unit load. So 1 kilonewton load, we will find out the reaction, shear force and bending moment. So then by using ordinate into unit load, then multiplication load into this ordinate will give the total reaction. So that is the influence line diagrams. So we'll go with one problem. Two wheel loads. So the problem will be like this. Two wheel loads 20 kilonewton and 15 kilonewton are spaced at 2 meters apart from each other, moved on simply supported beam at a span length of 10 meters. Find out maximum reactions and shear force at 3 meters from any support, as well find out bending moment. This is the problem statement. Two wheel loads of 20 kilonewton and 15 kilonewton are spacing at 2 meters apart each other on it is moving from support A to support B on a simply supported beam of a span length of 10 meters. So finally we are going to find out the maximum reactions. It's a very important point, we have to underline it, and shear force at a distance of 3 meters from either any support, either support A or support B, and also we are going to determine the bending moment. At maximum bending moment we are going to determine it. Nothing but here this 20 kilonewton and 15 kilonewton is nothing but vehicle loads. There are two vehicles are crossing from support A to the support B. So that is the main point we are noted down. So earlier we have seen the derivation of a influence line diagram for reaction RA and influence line diagram for reaction RB, and also shear force we have determined and bending moment also we have determined. So we have considered only for the 1 kilonewton load. Now multiply that load into the ordinate. That is the next thing we are going to do it. So now we'll solve it, the solution for this. First we have to draw the simply supported beam and we have to apply the loads. So the simply supported beam will be like this, having a span length of, it doesn't mean that L equals to 10 meters. and also two wheel loads of having 20 kilonewton and 15 kilonewton, they won't mention which is the first moving and which is the next moving. So either our wish, it is first load is 20 kilonewton or 15 kilonewton, that is up to our end. So I have taken 20 kilonewton just for example, but it's not exactly 20 kilonewtons. They have clearly mentioned maximum reactions. During that time, I'll explain you which is the first load. But for the sake of understanding, initially I have taken 20 kilonewtons. Now, already we know that the reactions, the first thing, this is the data they have given. It is moving from support A to the B. So first aim is to determine the reaction at support A and support B. It doesn't mean that we are going to find out the ILD, influence line diagram. We have to use it. So already we know for 1 kilonewton load, the influence line diagram for RA will be like this. So this is the shape of ILD for RA. ILD is nothing but influence line diagram. So the ordinate here is 1 and here is 0. So this is the shape of the ILD. Alright. So next they are going to asking about maximum reaction. So the maximum reaction is nothing but, we know that how to get the reaction, load into ordinate. So here 1 is the ordinate. Here load already they have given 20 kilonewton and 15 kilonewtons. See, if we want to get the maximum reaction, so then we have to keep maximum load on maximum ordinate, then it will give the maximum reactions. Exactly. So what I'm doing is, so this is the shape of the ILD. Having, if I'm keeping 20 kilonewton at 1 ordinate, then the 15 kilonewton will be how much? 2 meters apart. So this is the total 10 meters. Then it is 2 meters. The remaining will be 8 meters. So this is the position of our load. See, at 20 kilonewton, 1 is the ordinate. But what about at 15 kilonewton? We are going to determine the ordinate under 15 kilonewton. So already for 10 meters, the ordinate is 1. For rest of 8 meters, how much? So just cross multiplication, then the ordinate will be 8 divided by 10, therefore the ordinate value is 0.8. So under 15 kilonewton, the ordinate value is 0.8. Very simple. So now the final answer will be like this. Already we know the formula, load into ordinate. So then the reaction RA is equals to the 20 into 1 plus 15 into 0.8. So this is the final value. So this is the reaction RA. Right. So similarly for RB also we are going to determine. So for RB, so we will calculate like this. For RB, I'm going to next slide. So again I'm taking a simply supported beam. So same, again I'm keeping 20 kilonewton load and 15 kilonewton load, and these two are spacing at a 2 meters apart, and the length of the span L equals to 10 meters, and this is the support A and this is the support B. Now already we know the ILD for RB. So here at support B the ordinate is 1 and support A the ordinate is 0. So this is ILD for RB. So in the question they have clearly mentioned the maximum reaction they are going to asking. So now reaction RB equals to load into ordinate, the same. So for if we want to get the maximum reaction, then where we will keep the load here, so it is a reverse case. So now our 20 kilonewton load will be, we have to keep it at B. So if it is keeping 20 kilonewton at B support, then 15 kilonewton is left side we are going to keep. Right side is not possible. There is no ordinate on right side. So obviously we are going to keep. This is for 10 meters. 1 is the ordinate. So this is 2 meters apart. So the rest of the span length is 8 meters. Already in the previous reaction RA we have determined the same values. The here also will be reflecting. Right. Now find out RB value. Reaction RB equals to 20 into 1 plus 15 into 0.8. So this is the final reaction of RB, maximum reaction. So up to here we have determined the reaction ILD for RA and ILD for RB, reaction RA and RB. Now it's time to find out the shear force, maximum and minimum shear force we are going to determine at 3 meters from either support A or support B. We are a sentimental people, so now ILD for shear force. So now in this case, now what we are going to do, there is a simply supported beam, again having a span length of 10 meters. So here we are going to find out a shear force at 3 meters. I support A or B. As a sentimental person, I am taking my 3 meters is from left support. So this is, I am assuming x equals to 3 meters. So already we know the shape of the shear force diagram. ILD for shear force at C is, this is the negative shear force, this is x by L, and this is the positive shear force, L minus x by L. Right. So now we are going to determine first these ordinates, x by L and L minus x by L. Then we will get the ordinate values of this. So here x is 3 meters, 3 by 10, obviously it is 0.3. Then L minus x by L is nothing but 10 minus 3 divided by 10. Therefore, it is 7 by 10. The final value is 0.7. So this is 0.7. This is the positive shear force. This is x by L. This is 0.3. And this is a negative shear force. So if we see the negative and positive ordinate, if we summation is equals to the ordinate 1, is equals to the 1. Now it's very simple. Now our aim is to find out the maximum positive shear force. So where we will keep our loads. So again I am drawing this loads, 20 kilonewton and also 15 kilonewtons having 2 meters apart. So to find out the maximum positive shear force, we have to keep our 20 kilonewtons load under at point C. Then 15 kilonewton has to keep either right side or left side. Right side we are going to keep, because left side if we are keeping, that is the negative shear force. Now we will keep at the right side, then it will give the positive shear force. So this distance is, this is x equals to 3 meters, then the rest of the distance is 7 meters. So that for 7 meters the ordinate value is 0.7 and 2 meters minus it, then it is for 5 meters what is the ordinate. So just a simple cross multiplication, at here the value will be 0.5. For 7 meters it's a 0.7, for 5 meters the ordinate value is 0.5. So then very simple, in the same way how we have determined the reactions RA and RB, here also directly we are going to determine the maximum positive shear force. Maximum positive shear force is equals to load into ordinate, it is 20 into 0.7 plus 15 into 0.5 will give the maximum positive shear force under 15 kilonewtons. So now similarly we are going to determine the maximum negative shear force also. Maximum negative shear force, not minimum or normal shear force. Maximum negative shear force, how we are going to determine? The same way, if you will focus very confidently, see here, will get. So this is the maximum negative ordinate. So when we are keeping 20 kilonewton at this point, we'll get the maximum negative. Similarly, 15 kilonewton left side. So this is 3 meters of distance. So same. For 3 meters, the ordinate value is 0.3. For 2 meters minus, then 1 meter, how much? This is 0.1. So directly we will keep 20 into 0.3 plus 15 into 0.1 will give the maximum negative shear force at 3 meters from either support A or support B. So in this way we are going to determine the shear force. And finally, the last thing we are going to determine is bending moment. ILD for bending moment, already we have seen there is a simply supported beam having a span length L equals to 10 meters and the loads are 20 kilonewton and 15 kilonewton are spacing 2 meters apart. So now the bending moment at point C x equals to 3 meters is, the shape is like this triangle 0 0 and the central ordinate is x by L into L minus x. Now we are going to determine this x by L into L minus x value, then we'll get the ordinate value x by L minus x by L. This is 3 by 10 into 10 minus 3 will give 3 by 10 into 7, 21 divided by 10, therefore this is 2.1. So the central ordinate is 2.1 value. Very simple. See here also they are asking the maximum bending moment, positive bending moment. There is no negative bending moment over here. There is no value below the reference line. The entire ordinate values are above the reference line. So obviously the values are positive. So here we will keep our 20 kilonewton load at exactly point C. Then the ordinate is 2.1 into 20. Next, we have a doubt, either 15 kilonewton we have to keep left side or right side. So either you will keep left side or right side, the final value is the same because the right side ordinate and left side ordinate is same. So 15 kilonewton, either your wish, you have to keep either right side or left side. So under this ordinate, it is at a distance of x equals to 3 meters. This is 7 meters. For 7 meters, the ordinate is 2.1 minus 2, 5 meters. What is the ordinate value? Very simple. So, same final value, maximum bending moment. Maximum bending moment equals to 20 into 2.1 plus 15 into the ordinate value will give the maximum bending moment. So this is the, in this way we are going to determine the influence line diagrams for, I have taken in this session only 2 loads, is nothing but 2 vehicle loads I have taken. Similarly we have to take 3, 4, 5 similar vehicle loads we will consider, and we are going to find out the reaction, shear force and bending moment at different locations. In the next class we will see the UDL, uniformly distributed load, is acting over a span shorter than the span and larger than the span. So how this influence line diagrams will vary reaction, bending moment and shear force. So thank you.